So a little homework help on some of the volume questions that we had to go over. Um, so we'll start with the first one. The steps I want is identify the shape. This is a cone. Write down the formula for volume, 1/3 pi r squared h from the reference sheet. And we're going to substitute in the values that we know. Let the calculator do this, and what we get is 301. 0.59 something, and then it rounded to 59. We don't have to include units of the units of measure, but if we do, let's get them right. Feet cubed, and move on to number 7. So this is a pyramid, and there's a little bit of a trick in this one. What they're giving us is this the height of this triangle, but that's not the height of the pyramid. We want the height of the pyramid. So we need basically to be perpendicular to the base which is this square at the bottom, this 4x4 square, and it's got to go from the vertex, or the apex is actually what it's called in the 3D figure, this one point where all the edges come together. We got to go perpendicular to that base. Okay, and if you really look at this, if I show this more specifically off to the side here, what you have is this height of the pyramid, right? But what they give us is this slant height, or the height of the other triangle, which is 6. Now, another difficulty here, we'll have to assume that from this point straight down probably hits the exact center. So from the center to here is half of 4, which is 2. So another tricky part of that question. We'll need Pythagorean Theorem to find h. Okay, and this is how we'll do this problem. So this is just some algebra. All right, you can go ahead and leave it as square root of 32 rather than round and make some mistakes. So now we come back up here. The volume of a pyramid is 1/3 capital B times H. Now, I'm actually going to talk about what B is. B is actually the area of the entire base. So, in this case, since it's a square, okay, that B should be 4 times 4. Length and width are the same. So, got to make sure we show that. Okay, now we can replace B with 16, and the height over here with the square root of 32. And when we do that, we get 30.169. It asked for 2 decimal places. So we're going to say 17, and it looks like meters. Okay. Next one on our list. Okay. Same issue with the height of the cone. So there's a cone. What we have now is a cone and a cylinder. And we're going to have to add those together. So identify the shape. And again, let's go through the process here. What we have is they're giving us the hypotenuse of that triangle of 7. They're giving us a radius of 2, so that'll be the same over here. That's also a 2. And technically, even though this is sideways, that's the height of the cone. All right, so again, we're going to use Pythagorean Theorem. So I'll quick do this. And of course, there's more efficient ways, but this is probably how you were taught. So that's what I'm going with. So that's the height of the cone. Now, that's not the height of, well, actually, it is the height of this triangle as well, but it's the height of the cone that we were after. Okay, so now we'll come back over. We'll say cone plus cylinder. Sorry. So this volume is going to be 1/3 pi r squared h. Okay, and this one's going to be just pi r squared h. Now these h's are going to be different. Okay, so let's see that. All right, the radius is 2, and the height we said was square root of 45 for the cone. Okay. This cylinder still has a radius of 2, but it has a height of 5. If you look right there, that's the height. Even though it's sideways, the height is how far between the two bases, really. So that's what we have there. So what we get is 28.0993. I'm not going to round that yet. We shouldn't round to the very end, which is another reason why I didn't round that square root of 45. 62 point, calculator says 8319. Some other stuff I'm sure after it. What we'll do is we'll add them together, so the total volume is going to be 28. Let your calculator do this. I'm just going to write it to show what I'm doing, but I'm going to let the calculator do all that, and I get 90.93 when I round it, and that is also inches cubed. Okay, so that's that one. All right, let's try to fit one more. I'm going to keep it under 10 minutes, so hopefully I can do that. For these, what I happened to do was separate it into 3 prisms. Okay, I just did it that way. I call this prism A, B, C. Prism A, they're all prisms. Since they're rectangular prisms, instead of using volume equals base times height, I'm going to use for all of them volume equals length times width times height. Technically, that is your capital B. But I'm just going to make it easier. Straightforward problem here. So first thing is, you have to take a look at this one. Okay. It's got a height of 4. This is 3. And this depth here, we get from there, we assume it's the same depth the whole way, is 2. Okay. Now, I'm going to call that my height. I'm going to call this my length, and this my width for this one. So volume for, let's call it volume for figure A. Length times width times height. You don't have to write that every time, but I'm going to call it 4 by 3 by 2. It doesn't matter which order these are in. So then we get 24 for A. For B, a little tricky here. This is, since this whole thing is 6, and we said 3 here, that's also got to be 3. It looks like a height of 2, or a width, whatever we're going to call that, and then the depth of 2. So, all right, let's go with a length of, we'll call this our length again. Okay, so that's going to be 2. This width is going to be 3, and our depth or height is going to be 2. So the volume of B is 12, and the volume of C looks like it's 10 for the width, we'll call it. The length, we'll call it 5. Doesn't make any difference, and this is going to be our height of 2. Okay, so length 5, width 10, height 2. Either way, it's 100, and then we're going to get the total. And how's that look? Yeah, that looks pretty good. 136 is what I get. There's no units of measure, so there it is. Okay, so we'll get to the reverse problems on the next video.